Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Alhamdulillah wa salatu wa salam ala rasulillah wa ala alihi wa ashabihi ajma'in. Assalamu alaikum students. This is Hamza Noor, and today here I am with the solution of A-level mathematics 9709 paper 3 variant 2 October November 2020, and the solution to question number 1 and 2. The link is mentioned in the description above. So I uploaded the solution to question number 1 and 2 in the month of January, and since then I haven't got much time to make a separate recording for my YouTube channel. So खुशकिस्मती मेरी, luckily I got some time today, 25th April, Sunday early morning, to make a separate recording for you guys, for those students who watch my videos on my channel, and inshallah this video will be uploaded on the Facebook page as well. So if you haven't seen the question number 1 and 2 solution yet, so what are you waiting for? Just go and start watching that. We are starting with question number 3 onwards. Let's see how many questions we can solve in this session, because जितनी हिम्मत हुई उतने questions करा दूंगा, or else next recording inshallah very soon. Question number 3 is regarding the topic, the linear relationship of logarithms. For that purpose, your concepts of the basic logarithmic and exponential equations must be very strong enough. And those students who have studied from me throughout the year, they are witness that we have covered each and every topic in as much detail as possible. Inshallah, all the best to all of the students who are appearing for the O&A level examinations in June 2021 attempt. So let's deal with question number 3 and 4 first. Wait a minute, just sometimes it happens, the screen blacks out. Ya Allah, Ya Rahman, Ya Rahim. Alright, so question number 3 is saying that the variables x and y satisfy the equation 2 raised to the power y is equals to 3 raised to the power 1 minus 2x. Part A is saying that by taking logarithms, show that the graph of y against x is a straight line. State the exact value of the gradient of this line. So basically, the equation is given in the form 2 raised to the power y is equals to 3 raised to the power 1 minus 2x, and this equation can be rewritten in the form 3 raised to the power 1 divided by 3 raised to the power 2x. 3 raised to the power 1 is just 3. Now what you do is take ln on both sides. So ln 2 raised to the power y is equals to ln, and the whole term with ln is 3 over 3 raised to the power 2x. Now this whole equation can be rewritten in the form, if you apply the properties of log, ln 2 raised to the power y is equals to ln 3 minus ln 3 raised to the power 2x. All right. Now applying the power law, according to the power law, if ln x raised to the power n, so this power can be multiplied over here. It can become a multiple of ln x. It will be multiplied with ln x. So basically ln 2 raised to the power y, ln 2 raised to the power y can be rewritten in the form y ln 2 is equals to minus, I'm hiding this thing first, and what's the reason behind this, I'll just tell you in a while. I'm writing this term first and this term afterwards. So minus ln 3 raised to the power 2x can be rewritten like this, minus 2x times ln 3 and then plus ln 3. So basically what's happening over here, since from your O-level mathematics, IGCSE mathematics, ASP1, and since your grade 8, what you have studied, that the straight line equation is y is equals to mx plus c, where m is the gradient and c is the y-intercept. And what happens is that the graph of y against x is made over there. Okay, so from this general form of the equation, what you can say that the gradient of this straight line is basically the coefficient of x, provided that the y has been made the subject, isn't it? So what you are doing over here is you are trying to form an equation of the graph of y against x. Okay, you need to find the you need to find the value, you need to find the exact value of the gradient of this line. So y against x. So you have to make y the subject, and the coefficient of x would be whatever the coefficient of x is, it will become the gradient of this straight line in the exact form. And the rest of the thing is just the y-intercept. So first thing first, you have taken log on both sides, and here you can see that y ln2, a term which is ln2 is being multiplied by y, and on the right hand side of the equation, the x variable, the highest power of x is basically 1. So obviously this refers to the situation of the straight line. All right, so the coefficient of x is minus 2 times ln3, and this whole thing is multiplied by x, and then you have ln3. All right, so you will say that the graph of y against x is a straight line in the form of ay is equals to bx plus c. So you have to just mention this in one complete statement. Now you need to find the exact value of the gradient of this line. So you have to make y the subject. So y equals minus 2 times ln3, then divided by ln2. This whole thing is multiplied by x plus ln3 over ln2. So minus 2 times ln3 divided by ln2, this is supposed to be the exact value of the gradient of this line, and this is supposed to be your final answer. You just mentioned that the gradient of this straight line is minus 2 times ln3 divided by ln2. All right, let's come on to part B. Part B is saying that find the exact x coordinate of the point of intersection of this line with the line y equals 3x. Give your answer in the form of ln A over ln B, where A and B are integers. So in the earlier part, you formed an equation uh, in which you made y the subject. Here you have another equation, y equals 3x. Just keep y equals to y and solve the equation by the substitution method. So we can say that 3x is equals to minus 2 times ln3 over ln2. This whole thing is multiplied by x plus ln3 over ln2. Now what you can do is, you can since you know that ln2 is a common denominator under both of these terms, so you can rewrite this equation in this form as well. Minus 2 times ln3 multiplied by x plus ln3, and then whole thing divided by ln2, isn't it? So ln2 will be multiplied by 3x, so this will become 3 times ln2 and then multiplied by x. You know, always remember this thing, that this x is not being treated as a term of ln. This will not become ln2x. All right, there's a huge difference. So just consider this ln2 as a constant term in an exact form, 3 as a constant term, and 3 is being multiplied with ln2, nothing else. And this is equals to minus 2 times ln3, which is being multiplied by x, and then plus ln3. So what I want to do is find an exact x coordinate in the form of ln A over ln B. Just make x the subject of this equation. For that purpose, what I can do is 3 ln2 multiplied by x plus 2 ln3 times x is equals ln3. Now applying the power law of the logarithms. What I can do is take this constant term 3 into the power. Take this constant term 2 with the power. So this whole equation can be rewritten in the form like this. ln 2 raised to the power 3 times x plus ln 3 raised to the power 2 times x equals ln 3. As simple as that. What is 2 raised to the power 3? It is 8. What is 3 squared? It is 9. This whole equation can be rewritten in the form ln 8 times x plus ln 9 times x, and this whole thing is equals to ln 3. Now what I can do is take x common and then multiply it by ln 8 plus ln 9, and this is equals to ln 3, and ln 8 plus ln 9, applying the laws of logarithm, this becomes x times ln 8 times 9, which is 72. So this is x times ln 72 equals ln 3. Therefore, x equals ln 3 divided by ln 72. This is the, you have found the x coordinate in the exact form of ln a over ln b, where a and b are integers. All right, let's come on to question number 4, and the question number 4 is about trigonometry. यहाँ तक वर्किंग कॉपी कर लो आप लोग. All right, so here we have question number 4. Show that the equation tan theta plus 60 is equals to 2 times cot theta, and this can be written in the form tan square theta plus 3 root 3 times tan theta minus 2 equals 0. So just apply the expansion formula of tan a plus b. So tan a plus b is basically equals to tan a plus tan b upon 1 minus tan a times tan b. All right, so tan theta plus 60 is equals to tan theta plus tan 60 over 1 minus tan theta times tan 60, and this whole thing is equals to 2 times cot theta, which can be rewritten in the form of 2 times 1 over tan theta, which is 2 over tan theta exactly. So what's the value of what's the exact value of tan 60? And don't forget to convert your calculator into degree mode over here. The exact value of tan 60 is under root 3, so this becomes tan theta plus under root 3 divided by 1 minus root 3 times tan theta, and this is equals to 2 over tan theta. Now just cross multiply. Tan square theta plus root 3 times tan theta is equals to 2 minus 2 root 3 times tan theta. So what you need to do is just show that this quadratic equation can be formed, and just straight away 3 marks for this working. Tan square theta plus root 3 times tan theta plus 2 root 3 times tan theta minus 2 is equal to 0. Therefore, root 3 plus 2 root 3, this is 3 root 3. Therefore, tan square theta plus 3 root 3 times tan theta minus 2 is equal to 0. And here you solve, and you have just proved this part A. Coming on to the next part. The next part is saying that hence solve the equation tan theta plus 60 is equal to 2 times cot theta for the range theta lies between 0 and 180 exclusive. 0 is not included, 180 is not included, both are excluded from the range. Always read out the range carefully. All right, so in place of tan theta plus 60 is equal to 2 times cot theta, what you can do is just solve this equation, because you have just expanded the equation originally in first part, and you obtain this form, the quadratic equation in form of tan theta. So tan square theta plus 3 root 3 times tan theta minus 2 equals to 0. And now here you can apply the quadratic formula. So tan theta is equals to minus 3 root 3 plus minus under root b square, meaning 3 root 3 whole squared minus 4 times 1 times minus 2, and then divided by 2 times 1. So tan theta is equals to minus 3 root 3 plus minus, just put this thing, this whole thing which is under root in the calculator, 3 root 3 squared minus 4 times 1 times minus 2. This is 35. So under root में आ रहा है 35 and then divided by 2. So tan theta is equals to minus 3 root 3 plus under root 35 then divided by 2. Tan theta is either equals to 0.360. Tan theta is equals to 0.360, or you can say that tan theta is equals to minus 3 root 3 minus under root 35 and then divided by 2. This is minus 5.556 minus 5.556. So let's just solve this equation, and the range is given from 0 till 180 exclusive. So when tan theta is equals to 0.360, you will take the basic angle. Basic angle is equals to tan inverse 0.360. And what is tan inverse 0.360? And this is supposed to be 19.799. Okay, so 19.80. Alpha is equals to 19.80. And since you know that this is a positive value for tan theta, and tan theta is positive in the first quadrant and the third quadrant. Always remember, whenever you are solving the trigonometric equations, making this diagram is very much important. You need to locate the exact quadrants where the solutions are lying. So इसकी जो है वो आपको बड़ी खूब अच्छी किस्म की practice चाहिए, and I hope that has been done. So, and always remember that the alpha, the basic angle, always lies between the slant line and the horizontal axis. Always between the slant line and the horizontal axis. So 19.80 over here and 19.80 over here. All right. So basically what happens is that in order to find the solutions, after locating the angles in their respective quadrants, basically what you do is, since your range is positive over here, you will go anti-clockwise from the origin axis till the slant line. जहाँ जहाँ तक slant line दिख रही है वहाँ वहाँ तक आपका जो है वो like ये arrow जाएगा और वो angle आपको निकालना होगा. So one solution, theta is equals to 19.80, and the other one is 180 plus 19.80. This could have been the solution if the range was extended up to 360 degrees, but in this case, the range is limited to 180. So we will just stop over here. Theta is equals to 19.80. Other one is ignored. This is out of the range. You will just mention that whatever the value of 180 plus 19.80 is, just mention it is ignored. And then you have tan theta is equals to minus 5.556. So whenever you are finding the basic angle, always ignore the negative sign. What you have is tan theta is equals to minus 5.556. So alpha is equals to tan inverse 5.556. Always ignore the negative sign whenever you are finding the basic angle. So what is this? Tan inverse 5.556. This is 79.80. Alpha is equals to 79.80. But since you know that this is a negative value of tan theta, and as we know that tan theta is positive in the first quadrant and the third quadrant, the sequences like all sine, tan, cos. So tan theta is positive in the first quadrant and the third quadrant, so tan theta is not positive in the second quadrant and the fourth quadrant. You'll just locate the slant lines over here. And always remember, the basic angle always lies between the slant line and the horizontal axis. So 79.80 over here and 79.80 over here. Now, in order to find the angle, since your range is positive, you will go anti-clockwise from the, you know, horizontal axis till the slant line. जहाँ जहाँ तक slant line बने, वहाँ वहाँ तक आपने जो है ये angle measure करना होता है. So obviously the first one is within the range, within the required range of 0 and 180. All right, between 0 and 180, the second one will be ignored. What is the required angle over here? 180 minus 79.80, and this is supposed to be 100.2. So theta over here is basically 100.2 degrees. The second one will be ignored. So the two solutions of this equation, which is exactly the same thing as solving this equation, which you obtained in the earlier part. The solutions are theta is equals to 19.80 and the second one is 100.2. Theta is equals to 19.8, 100.2.